Ayan. Okay, so discuss natin ngayon is tayo, power losses na tayo and efficiency ng isang DC generator. So, meron tayong losses, iba't ibang losses yan for a DC generator. So, unahin natin yung copper losses na tinatawag. So, that is number 1. Yung copper losses, that is PCU. Okay? So, yan ay yung I squared R losses natin for your windings. So, yung formula natin, ang formula natin for power losses or for copper losses is that we have PCU is equal to IA squared times RA plus ISH squared RSH plus ISE squared RSE. So again, pag subscript IA, that is for the armature winding. Kapag SH, yung subscript yan ay shunt, yung sa shunt winding, and yung SE doon sa series winding. Okay? So we have copper losses. And then for the next, meron tayong tinatawag na core losses, that is PCO. And then meron kang two types, meron kang dalawang core losses. So under core losses, you have hysteresis loss, PH, and eddy current loss, PE. And then the next one, syempre kasi di ba generator yan, so meron yang mechanical action. And then due to mechanical action, meron kang mechanical action, mga friction, di ba? Frictional forces. So you have your mechanical losses, or that is PFW. So ang FW, sabihin yan is friction and windage. Okay? So yun yung losses natin for mechanical. So we have PFW, or that is friction and windage loss. Okay. And then we also have what we call the next fourth one. We have stray loss, stray load losses. Okay. That is the P stray. So P stray, madali lang kunin ng P stray. So ang P stray na yan, ina-add lang natin yung core loss. So, ina-add natin to, tsaka yung mechanical losses. So, we have PCO plus PFW. Okay, so pag sa problem natin, okay, pag sa problem, minsan, itong copper losses, hindi siya given. So, you need to solve for the copper losses using this formula. Okay, ito yung formula natin. And then, ang given sa problem minsan is either stray losses na kagad ang binibigay, or itong dalawa. You have PCO or PFW. So kapag binigay ang PCO tsaka PFW, pag pinag-add mo yung dalawa na yan, that is now the stray losses. And then yung copper losses natin, kailangan pang isolve. So using this formula. So and then after that, alam na natin yung different types ng losses. Kukunin natin ngayon yung total ng losses. So, syempre, pag kinuha natin yung total power loss, add lang natin yung lahat ng losses. Or that is just yung copper loss, okay? Copper loss plus your stray load losses. And then again, your stray load losses is equal to PCO plus PFW. So, kung kukunin natin yung total power loss, so we have your copper losses, plus your core losses, plus your friction and windage losses, or that is the mechanical loss. Okay? And then once we obtain the power loss, the total power loss, we can now solve for the efficiency. The efficiency, alam natin yan na efficiency, simple lang. Output power lang yan divided by the input power. So, ganun lang siya. So, para naman makuha yung input power, okay, para makuha yung input power natin dito, okay? So you just, ang formula natin for P in, it is just P out plus P losses. Okay? So our formula for the efficiency is power output over your power output times your losses. So, and then, para makuha yung so to get for the percentage, Okay? Kasi naka-percent ito. So you just multiply this by 100%. So para naka-percent yung ating efficiency. Okay? So solve tayo ng problem. Sabi ko nakaraan, di ba? Solve tayo ng problems. So hahaluin ko yung problems natin. Merong pag-solve yung sa iba't ibang types ng generator. And then meron ding ibang problem na may dalawang problem dito na kinukuha na yung efficiency ng ating BC generator. Okay, so solve tayo ng ating let us solve for the for solve tayo ng problem. Unahin natin ito. We have a problem here about this is about this is separately excited generator. Ito yung ating problem. Lakihan ko lang to Yan. Yan. So, ang problem natin na una, okay. So, our first problem, okay. So, our first problem here is that the armature of a separately excited generator, okay. So, yan, binanggit niya yung type. It has a resistance of 0.16 ohms. When run at its rated speed, it yields 132 volts on open circuit, okay, and 126 volts on full load. So solve for the armature current, so IA, and the power delivered to the external circuit. So we'll solve for this one. Okay. So let us draw a separately excited generator. So pag drawing natin yan, so again, ito yung figure natin. So simple lang itong figure. So you have your E again, then you have your RA, and then this is your load. Okay. And then we have your VL. Okay. So ang given sa problem, okay, ito sabi niya, the armature has a resistance of 0.16 ohms. So given natin, okay, so yung ating resistance ng sa armature, okay, armature is 0.16 ohms. So we have 0.16 ohms. Okay? And then, ito ang nakakalito dyan. Ang sabi niya kasi, 132 volts on open circuit and 126 volts on full load. Sa atin ilalagay yan sa iba o sa VL. Yung nakakalito dyan. So para makuha natin yan, so yung pag sinabi natin yung voltage is at open circuit, okay? Pag sinabi na sa open circuit, yun yung rating, yun yung voltahe. So kapag open circuit, that is your E. So you have 132 volts in here. And syempre at full load, that is on your load side. So you have 126 volts in here. Okay? So now, we can now solve for the armature current. So ito yun. Solve natin to. IA. Okay? And then we have your IL in here. And then sa natin nakaraan, we have a formula that your IA is equal to IL. Okay? And then the formula for IL, okay, our formula is okay, yung formula natin, di ba, for IA, we have your E minus VL. Ay natin nagagamit yung isang formula natin eh. Yung IL natin, di ba, nakaraan ang ginamit natin ay ano to? Yung ginamit natin formula for IL, yung PL over VL. Kaya lang wala tayong PL. So wala tayo nitong PL. Okay? Wala tayong PL. Ito meron tayo yung VL given. Ang given kasi sa atin yung E tapos yung RA. So para makuha natin yung IA, yung isang formula natin. Kasi di ba we have the formula E is equal to VL plus IARA. Okay? So given ito, given din to, given din to. Ito ang hinahanap. Okay? Yung IA. So, kunin natin yung IA o algebra lang tayo. So, we have IARA is equal to E. Lipat sa kabila yung VL minus VL. So, you can solve for IA. Okay, IA is equal to E minus VL over RA. And then, substitute lang natin yung values for IA. Okay? So, ba't yung values for IA? So, E is 132 volts minus your VL, 126 volts over RA. So, 0.16. So, gamit tayong calculator. So, that is equal to 37.5 amperes. Okay, so ito yung sagot natin for IA. And then, may isa pa siyang tanong. Okay na to. May isa pa siyang tanong. We need to solve for the power delivered to the external circuit. So, to solve for the power delivered to the internal circuit, so pag sinabi natin internal circuit, doon yan sa load side. Okay? Yung external circuit na to, okay? External circuit in here refers to the power doon sa load side. Yep. That's it. Okay. So, load side. So, we refer to the load side kapag sinabi niya external circuit. So, we need to solve for the power delivered to the load side, yung sa load. So, ang formula natin, syempre, power. So, we use the yung power formula natin. That is, syempre, load side tayo. So, we have a subscript L. So, PL is equal to VL times IL. Okay? So, nasolve na natin yung may given na VL. Okay? And then, yung IL, sabi natin, di ba, equal yan? So, we can now use yung value ng IA as your VL. So, we have 126 volts times 37.5. Okay. Multiply lang natin itong dalawang to. So, we now have 4,725 watts. So, ito yung ating power delivered to the external circuit. Okay. So, may tanong kayo before we proceed to the next problem? Madali lang, no?
Wala pa, sir.
Madali pa siya.
Okay lang. Opo.
Sige. Next tayo. Madali pa lang siya. So, next problem tayo. Doon naman tayo sa isa. Sa series circuit, sa series, tawag dyan, series generator tayo. Okay. Yan. So, our next problem is we have a series generator that delivers a current of 100 amperes at 250 volts. The armature and the series field resistances are 0.1 ohms and 0.05 ohms. We need to determine the generated EMF. So ito ang tanong, generated EMF. So we draw the series generator. So pakita lang natin yung itsura. So we have your armature, then you have your E, generated EMF, you have your series field, winding, resistance yan, then load side. Okay. So we have ito yung ating series, ito yung ating load, ito yung ating armature, ito yung ating generated EMF. Then we have your VL. Okay. So from the given, so a series generator delivers a current of 100 amperes at 250 volts. So sa ganitong problem, okay, 100 amperes daw, may di-deliver siyang 100 amperes. So yung delivered current na yan, di ba meron tayo ditong IA, tapos IL dito. Okay. So itong binabanggit dito na 100 amperes at 250 volts, yan yung nasa load side again. Kasi yun lang yung kayang i-read ng ating mga tester or ng ating mga multimeter, voltmeter man yan, at saka voltmeter and ammeters. Okay. So kaya pag may binigay siya na ganito, and then it delivers this current at that voltage, so your 100 amperes na to, that is your IL. Okay? And then this 250 volts, syempre yung voltahe on your load side. And then, kasi ito hinahanap natin pati yung E. Okay? And then, binigay na rin yung armature resistance, okay, 0.1 ohms. That is 0.1 ohms and 0.05 ohms respectively. Yun ang nalagay. So, nauna yung armature, 0.1. So, we have 0.1 ohms. And then, RSE is 0.05 ohms. So, solve na natin yung generated EMF. So, ang formula natin nakaraan is E is equal to VL plus IA times RA plus RSE. Okay? Yan. So, sabi natin, as this is a series generator, so again, IA is equal to IL. Okay? Equal yan sila. So, yung IA natin dito is 100 amperes. So, substitute natin. So, VL is 250 plus IA, which is this one, 100. Since series to. RA natin, 0.1. And then yung ating RSE is 0.05. Ayan. So, ngayon, calculator lang natin yan. And then yung ating E is now equal to 265 volts. Okay? So, may question? Question kayo dito? Madali pa lang, no? Hello?
Sir, wala pa, sir.
Ah, ah?
Okay pa siya, sir. Okay pa.
Sige. Nawala pala ako. Sige,
Hindi
medyo
okay.
madali lang naman yan. Series. Madali lang kasi yan yung series tsaka yung separately excited. May signal ko ngayon Okay naman. Wala man nakalagay na naka-disconnect ako. Okay. Last two problems tayo before we end yung ating session. Tigat lang yung meeting natin. Sunod natin yung sa shunt generator. Ito yung problem. Okay, so ito yung gamitin natin. Ito yung problem natin for the next one, sa shunt generator. So, a shunt generator, okay, so shunt generator. A shunt generator, again, delivers. So, alam natin yung pagsabing delivers this current, doon yan sa load side. So, meron kang 50 amperes of current to a load. Ayan na, to a load at 110 volts. Ayan. Its armature and shunt field resistances are 0.1 ohms and 65 ohms, that is respectively. And then, nabanggit na yung losses. The total constant losses are 480 watts. Okay? Constant losses are 480 watts. Okay? So we have to solve for the generated EMF and the efficiency of the generator. Okay? So, draw natin muna ulit yung shunt generator. So, we have your armature winding resistance. We have your generated EMF. And then we have your shunt field resistance. And then to a load. Okay? So, you have your RL. RL. RSH. RA. And then we have your E. And then, drawing natin. PL. Okay. So, pag drawing na natin yan, we have your IA, ISH, and IL. Okay? So, we have in here, okay, sabi sa una, di ba, 50 amperes yung delivered current. So, that is your IL, 50 amperes. So, that is at 110 volts. So, we have VL of 110 volts. 110 volts. And then, your armature is 0.1 ohms. Okay, lagyan natin dito. And your RSH is 65 ohms. Ayan. So, susolve natin ngayon yung generated EMF. O, uh, so, to solve for the generated EMF, okay, ang formula natin nakaraan is E is equal to VL plus IA RA. Ito yung formula natin nakaraan. Okay? So, um, wala tayong IA, di ba? So, we need to solve for IA first. So, yung IA natin, we need to solve muna yung ISH. Okay? So, to solve for ISH tayo. Okay? So, sabi natin, this is a shunt. Di ba? Naka-parallel. And then, ang formula natin dyan is VL over RSH. Okay? So, VL natin, given na siya, 110 volts over your RSH, 65 ohms. So, ang ISH natin is 1.69 amperes. Okay? Ito. And then, nakuha na natin yung ISH, we can solve for IA. Okay? So, yung IA natin, is equal to ISH plus IL. Okay? So, ISH is 1.69 amperes plus your IL, we have 50 amperes. Right, hindi calculator. Alam natin siya na 51.69 amperes. Okay? And then, masolve natin yung IA, given na yung VL, tsaka yung RA. So, we can solve for that. So, E is equal to VL, 110 volts, plus IA, we have 51.69 amperes, times your RA, we have 0.1. Okay? So, ang sagot natin, 0.1 nito. So, ayan na. Add lang natin ito. So, 115.169 volts. Okay? So, yan na yung ating generated EMF. Okay? May tanong kayo before we proceed to the next? Pag-solve ng efficiency?
Wala po,
Okay naman.
sir.
Okay. Sige. Malinaw naman. Sige. Doon tayo sa pag-solve ng efficiency. That is for letter B. So, sa efficiency natin, di ba? Sabi natin we have core losses. We have copper losses. Okay. We have friction, windage losses. Pag pinagsama natin itong dalawang to, yung copper, ito, pinagsama natin itong dalawang to, okay, that is your stray losses. Okay? So, ang nabanggit na ang binigay na losses dito sa problem na to is 480 watts. Constant losses. So, what do we mean by constant losses? So, yung constant losses na yan, okay, yung constant losses, yan na yung ating stray losses. Okay? So, the constant losses is the stray load losses. So, for letter B, so natin yung given. Okay? So, our given is, ang binigay is the P stray at 480 watts. Okay? So, ngayon, ang hindi given sa atin, lagi yan, is the copper loss. PCU. Okay? So, ang formula natin, di ba? Ano yun? IA squared R times RA plus ISE squared RSE plus ISH squared RSH. Okay? So kaya lang, kung mapansin nyo sa ating figure, di ba? Ang meron lang tayo is the armature. Okay? Armature lang meron, tsaka yung shunt. Yan o. Armature lang, RA, tsaka yung sa shunt. Yan lang meron tayo. Wala tayong series field winding. So, wala tayong series field winding. So, wala ito. Part na to. Cancel natin yan. So, we now have yung dalawa lang. We just have the armature tsaka yung sa shunt field na copper losses. So, solve natin yan. Dito natin lagay. Ang mga bayan. So, init na lang. Okay. So, IA squared, na-solve natin. We have 51.69 squared times your RA given doon sa taas. That is 0.1 plus doon tayo sa ISH. Ayan o, 1.69 squared times yung RSH. We have 65 ohms. So, susolve natin to. Okay, using calculator. Yung ating PCU is equal to 438.55 watts. So, ito na yung PCU natin. And then we have the P stray. So, we can now solve for the efficiency. Efficiency tayo. So, efficiency is equal to P out, okay, over P out plus ang ating losses. Okay? So, P out natin. P out. So, solve natin muna yung P out. So, ang P out, para makuha ang P out, okay, that is just yung doon sa output. Yung output natin nasa load side. Okay? Yung nasa load side. So, we have P out. So, we have BL, VL times IL. So, ang VL natin is 110 times yung IL. We have, ano lang IL natin? 50. Yan. So, multiply natin yan. That is, ayan o, 5,500. Yan. 5,500 watts. So, kompleto na to. We have P out, P stray, tsaka PCU, or copper losses. We can now solve for the efficiency. Okay? So, ang P out is 5,500 watts over 5,500 watts, which is P out, plus your losses. So, ang losses natin, dalawa lang. Itong stray, tsaka yung copper losses. So, add natin yan. So, we have 480 plus 438.55. And then, syempre, para percentage makuha natin, times natin to sa 100%. So, ang sagot natin makukuha for the efficiency, okay, efficiency is equal to 85.698, 689. 689%. Okay? So, this is the efficiency of our shunt generator. Okay? May tanong kayo? May tanong kayo for solving the efficiency? May generator? About solving efficiency?
Pag sa losses, sir, constant na yung copper na loss, sir.
Kapag?
Pag pinapakuha yung losses, sir.
Alin?
Pinapakuha
Saan
yung
dito?
losses, sir. Yung sa losses.
Saan dito banda?
Yes, may P output tapos may P losses din, sir. Yung stray lang kasi yung given, sir. So, kaya Parang may concept na
Ito.
yung, oo, copper talaga, sir.
Ito yung copper. Ito yung formula niya. Ito. Ang formula kasi natin for copper, ito na yon. Ano yun, nasa taas eh. Yan no? Ang formula natin for copper losses, oops, wait tayo dito. Ito na yung formula natin for losses, copper losses. Ayan, ito. Okay, ano naman yun, pag dyan, shunt generator siya. So, pag shunt generator, ang meron lang dyan yung sa armature. Pag shunt generator, ang meron lang dyan yung sa armature tsaka yung sa shunt. Okay? So, kaya wala yung ISE natin na to. Pero mamaya, may example tayo na tatlo yan meron. Kasi kapag compound generator, meron kang armature, shunt, tsaka series. Tatlo na to. Okay? Kapag series naman, yung meron lang dyan yung armature tsaka yung sa series. Okay? Ganyan siya. So, kaya na-cancel natin yung term na to. Yung ISE squared plus RSE. Kasi wala tayong series field winding. Okay? For a shunt generator. To, so, meron lang tayo is the armature, to, tsaka yung shunt. Wala tayong series. Okay?
Yeah, correct, sir.
Okay. 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 Sige lang.
Sir,
Ah,
di ba lagi, iba yung maglabas sa calculator ko ba na ano, yung
saan? Iba ba?
sa
Yung,
copper
sige.
loss ba
Hindi
yun?
ko yata kasi titingnan ko lang kasi yung notes ko eh. Yung calculator natin ha.
Sige
Wait.
lang, sir.
Wait. I-full screen ko lang to. Ay. May screen tayo na sharing. Ayan. Sige, try natin sa calculator ha. Ito, on natin to. Ayan. Kasi kina-calculator eh. Calculator ka natin. Verify natin kung tama yung ano natin. Yung losses no?
Opo,
Copper.
opo. Yes po.
Copper. Sige. Copper losses. Solve natin. Buti may calculator ako dito. 51.69 squared times yung 0.1. Dati baka may mga talaga. 1.69 squared times 5. Ay, ang RSH pala natin ay mali ang nalagay ko pala. 60 lang pala to.
Ah, kaya pala.
Kaya pala. Yan. Ano ba? Ay, teka.
Oo,
65
sir.
nga dito, no?
65
Ay,
siya, sir.
65 nga. 65 nga. Mali yung ano ko. Ang nalagay ko kasi pala 6. Ano ba nalagay ko? 60. 60 yata nalagay ko dito eh. So, dapat pala 450. Okay. Correct natin to. So, this is dapat 452. Mali yung nandun nakalagay sa aking kodigo. Okay. So, sabi niya dapat ay 452. Okay. So, magbabago yan. So, 452. 452.832. Ito yung 832. 832. Ayan. So, mapapalitan to. Magiging 452. Nako. May typographical error pala siya doon. Ito yung sa ano nyo, yung nandoon sa additional notes na in-upload ko. I-correct nyo na lang din yan nandoon. 0.832. Ayan. So, compute natin yung losses. So, 5500 plus 5500 plus 480 plus 452.832. Siyempre, times natin to sa 100%. Yun, 85.489 or 499 or 499. Okay? 85.499. Okay. Ayan.
Apa,
Okay na?
sir.
Or
Pa,
80 or 85 point, pwede na 85.5.
0.5.
Okay. Sige. Okay, at least na-correct natin yan. Mali yung nakalagay dito sa kodigo. That is, oops. Edit natin to. Dapat ay 65, di ba? Yan. Sagot ay 452.832. Kaya natin ito nasa kodigo. Yung sa lecture notes. Tama na. Yan. So, ito pa. So, 80. Tama. So, kahit 5 na to. Kahit 5. Okay. Napansin natin yung mali doon sa notes. Okay. So, may tanong pa? Baka may mali pa tayo. Tama na rin naman tayo iba. Okay.
Tama naman yung iba, sir.
Oo.
Yun lang. Confused
Sige,
masyado
thank you.
ako bakit iba
Oo
lumabas.
nga eh. Ba't iba lumabas na? Sige.
Oo.
I-calculate natin mamaya yung iba. Last
Tama
problem
po,
na rin.
sir.
Last problem na rin tayo. Makapahinga tayo maaga-aga.
Paranoid na, sir.
Oh. Alright.
Kasi baka iba setting ng calculator ba, yun yung...
Wala naman yan kung kasakali, di ba, naka-radian or degree. Wala kang pinagkaiba yun.
Kaya nga.
Sa ano lang yung nagmamatter kapag trigonometric functions. Ayan. Sige. Last round tayo para makapahinga na tayong maaga. Sabi kasi rin, klase natin 3:30 to 7. Yeah, mahaba man. Pahinga tayong maaga. Meet na tayo ulit. Siguro mag-meet pala tayo ulit bukas. Okay lang ba?
Okay lang, sir.
Kasi alis kami ng Thursday, Friday. So dumarang kami. Okay lang?
Yes po, sir. Okay lang.
Sige, thanks. Okay, 3 p.m. siguro bukas. Okay lang? 3 p.m.
Pwede sa akin,
May
sir,
klase
pwede
ka
sa
ba?
3 p.m.
May klase ka
Ano
ba?
lang, hanggang... Tama lang din, sir, hanggang 3 p.m.
Sige,
Tapos,
sige. 3 p.m. na lang. Sige, 3 p.m. Okay? Sige, last problem tayo. Parang makapahinga na kayo. Yung klase mo ba, Miss Luzano, buong nagsimula kayo ng umaga pa?
meron ding sir, yung... Like kanina, walang klase yung subject.
Walang klase kanina.
Po. Yes po.
Sige. Okay. Last problem tayo. So, yung last problem natin is a short shunt compound generator. Okay, so we have a 50 kilowatts, 250 volt short shunt compound generator. Has the following data. So, ito yung data ng ating generator. So, armature resistance is 0.06 ohms. Series field resistance is 0.04 ohms. Shunt field resistance is 125 ohms. So, we need to calculate for the induced voltage at rated load and terminal. And we solve for the efficiency if the stray load losses is 2 kilowatts. Okay? Stray is 2 kilowatts. So, ang given natin for this, we have, drawing muna natin yung figure natin for a short shunt compound generator. So, kapag short shunt siya, okay, pag short shunt, check ko lang saan yung short shunt natin dito. Oops. Okay. Kapag short shunt yung ating generator, so we have ang short shunt, we have armature, then the induced EMF, yung ating E, and then we have ito yung ating series, shunt pala, and then pag short shunt, naka-series sa load yung ating series winding. Okay? So we have your RA, and then we have your E, generated EMF, and then RSH, we have your RSE, and then your RL. So we have VL. So we have your current, IL, ISH, IA, ayan. Okay. So data tayo. So ang sabi sa data, we have 50 kilowatts to 50 volts. Okay? So yung 250 volts, pag nagabanggit tayo ng voltahe na nandito, hindi binanggit, di ba? So that is your VL. So we have 250 volts. And then the data, armature resistance, 0.06 ohms. Series field, 0.04. No? And then shunt field is 125 ohms. So calculate natin ang okay to, induced voltage. So ang induced voltage same na rin yan sa generated EMF. So we need to solve for E. Okay? At the rated load and terminal. So ito yung kapag sinabing rated load and terminal, yung rating ng load. Okay? So ang rating niya is this one. Okay? So 50 kilowatts to 50 volts. So yan yung induced voltage. So we need to solve for the induced voltage E at this voltage and this load. Okay? So solve natin yan ngayon yung E. So kaya lang para solve natin yung E, di ba? Ang formula natin mahaba siya. So we have IARA. Easy lang pala siya, no? Sabi natin kanina nakaraan yung kahit dito sa loop na to plus VL. Plus hindi siya VL, VSH plus VSH. Kasi nag-iba na yung voltahe natin on the shunt field dito sa part na to. Okay? So, solve muna natin yung ating IL. Okay? Solve natin yung IL. So, IL nakaraan, ulit natin yan. PL over VL. So, may PL ka, itong 50 kilowatts. So, 50,000 yan. Over VL, ito, 250 volts. So, ang sagot natin for that, i-calculate natin para sure tayo. Diba? Ayan. I-calculate natin siya. So, we have 50,000. Okay? 1,000 yan over 250. So, 200 amperes. Tama naman. 200 amperes. Okay? Yan yung IL natin. And then the next, okay? Meron tayong VSH dito, di ba? Meron tayong voltahe dito. VSH. So, to solve for the VSH na nandito, okay? Ang formula natin dyan nakaraan, di ba? For VSH is VL plus IL times RSE. Since equal naman yung IL ito yung IL, yan na rin yung current for your RSE. So, kaya IL times RSE tayo. So, to solve for this, substitute lang natin. So, we have VSH. We have 250 plus IL. Ito nakuha natin, 200. Times RSE, yan o, 0.04. Okay. So, calculator natin to ulit. Yan. So, 250. 200 times 0.04. Ayan, 258. Okay. Since voltahe yan, so volts ang unit. 258 volts. Okay. And then solve natin kasunod. ISH tayo. Okay, ito ISH. O, ang ISH, meron kang VSH, at saka RSH. So ISH is equal to VSH over RSH. So simple lang, Ohm's law. So, VSH is 258 volts over yung RSH, 125 volts. I mean ohms. So, 258 over 125. Ito yung sagot to. S to D. So, we have 2.064 amperes. Okay? And then once you get the ISH, we can solve for IA. Sabi natin nakaraan. Yung IA is ano to? I-add lang natin yung IL tsaka yung ISH. So we have 200 plus 2.064. Hindi natin i-calculate yan. Matic. So we have 202.064 amperes. Okay. So after that, we solve for that. We solve now for the generated EMF or the induced voltage. So E, lagay ko yung formula. Okay, pwede ang ganito, VSH plus IARA. Okay. So VSH, we have, na-solve natin yan, ito, 258 volts plus IA, na-solve natin yung IA, ito, 202.064 times RA, ayan, 0.06. Baba lang. So, ang E natin, or the induced EMF, or the generated voltage, is equal to, also dahil sa calculator. So, we have 258, oops, 258 plus 202.064 times 0.06. So, we have 270.12. Okay, that 0.12. So, we have 270.12 volts. Okay? May tanong kayo? Before we proceed to the efficiency?
Wala, sir.
Okay, sige. Efficiency tayo. So, tandaan natin na binigay niya yung stray load losses, which is 2 kilowatts. Okay? Ito binanggit niya sa problem. Ito. Okay, the efficiency if the stray load loss is 2 kilowatts. Tandaan natin yan. So, sige tayo sa efficiency. Oops. Yan. So, ang sabi niya, okay, ang sabi niya, ang stray load losses, ang stray loss is 2 kilowatts. Okay, 2 kilowatts yan. Okay, and then we solve for the copper losses. Okay, so sa copper losses, ang formula natin is IA squared RA plus ISE squared RSE plus ISH squared RSH. Okay. So ngayon, okay, meron tayong IA, RA, okay, ISE, meron tayong ISE. Kaya lang, ang ISE natin, wala tayo dito, di ba? Pero, equal yan on your IL kasi naka-series naman ang connection nito ng RSE tsaka ng RL. Naka-series yan. So, kung pwede gamitin na current ng RSE yung IL. So, you can say that your ISE, yeah, ISE, ay magsulat. Yan. So, yung ISE natin, ito. So, ang ating ay magsulat Loko I. Oy. Magsulat. Wait lang. Oy. Ano ito Oh. Yan. Loko nga. Yan. So, ang ISE natin, sabi natin, since series ito, equal sa IL. And then, meron tayong ISH. Ito. Solve natin yung kanina. Ito siya. Tsaka yung RSH given. So, ayos natin yung formula ng konti. So, ang formula natin is PCU is equal to IA squared RA plus yung ISE natin, IL. So, we have IL squared times RSE plus ISH squared RSH. Okay? So, substitute natin. So, PCU natin is equal to IA. Ang IA natin, ito, 202.64 squared times your RA, 0.06 plus IL. So, ang IL is 200 squared times RSE. Ang RSE natin ay 0.04. And then, kasunod, ISH. Solve natin yan. 2.064 squared times 125 ohms. Okay. So, calculator natin to. So, we have 202.64. 0. Ano ba yun? 202.064 nga, no? Yun. Kamay tayo dito. Oh. Oh, 202.064 and 064 squared. Okay. So, 202.064. Okay. Squared times 0.06 plus 200 squared times 0.04 plus 2.064 squared times 125. So, yan ang sagot natin. Tama? Parehas ba?
4,000.
Tama? Parehas? So, that is 4582.30 watts. Or in kilowatts, that is 4.582 kilowatts. Okay? Ito yung PCU. Okay? And then, output power. Okay? P out. Paano ang P out? Balik ka sa problem. Meron na siyang binigay dito. So, yung P out kasi yung nasa load. So, sabi nito, a 50 kilowatt generator. So, yung 50 kilowatts na yan yung output power ng generator. So, 50 kilowatts, yan yung output power. We don't need to solve. Okay, P out is 50 kilowatts. So, lahat ng unit natin naka-kilowatts na for stray. P out tsaka PCU, naka-kilowatts na yan. So, we can now solve for the efficiency. Kompleto na yung losses natin. Okay. So, efficiency tayo. So, efficiency. So, P out. So, dito natin yung formula. So, sige natin. P out over P out plus P losses. So, P out natin. So, 50. Okay, over 50. So, naka-kilowatts yan. Losses natin, ito, PCU. 4.582. Ano pa isang losses natin? Stray. So, plus 2. So, then, multiply natin to sa 100%. Okay, so, kung nakuha natin yung sagot. So, 50 over 50 plus 4.582 plus 2. Multiply natin ng 100% para percent siya. So, ang sagot natin is 88.2%. 30, 36.7. So our answer for the efficiency is 88. Point 367. Okay? Yan. Oh, nawala ako, pambira. Ano kung ano yun? Okay, kita ba ako? Okay na ako ulit?
Opo, sir.
Nawala ako sa
Yes
glass.
po.
So may tanong kayo dito for for solving efficiency. Ito sa office kaya medyo may ilang connection dito. Tanong kayo? Wala na rin?
Answer.
Madali lang. Jeff, ram ko Kasi nakatulog ko kanina Thanks. Wala nang tanong, no? Okay, so yan yung ating discussion for today.
Sir.
Madali lang naman yan. Efficiency, power losses, tapos mga problem natin for the different types ng generator. Nakasolve tayo ng shunt, ng series, separately excited, tapos compound generator. Okay? So, nakasolve tayo ng 4. Okay? So, bukas, mag-meet tayo bukas saglit ulit. Start tayo siguro ng 3 o'clock. Okay. So, ang gagawin natin, bukas, doon tayo sa sunod na unit natin, doon tayo sa DC motors. So, ang DC motor, binaliktad lang na generator. Kasi kung ang generator is from electric, from mechanical, to convert yung mechanical energy to electrical energy, ito baliktad. So, from electrical energy, gagawing mechanical energy. So, yun ang gagawin natin. So, solve natin yan, yung, discuss natin bukas ang DC motors. And then, wala lang ganong pinagkaiba yung DC motor sa DC generator. Halos parehas lang yung analysis natin sa pag-solve ng problems. Kaiba lang ngayon kasi medyo baliktad siya. Baliktad. Okay? So, bukas, discuss tayo. And then, Thursday, Friday, wala muna tayo kasi sa biyahe. So, next week, after tomorrow, Wednesday, Tuesday ulit, sunod. Okay?
Opo, sir.
Sige.
May nangyari kasi doon sa babae doon na bumagsak yung kasama ako.
Ayan.